Hello, everyone. Pleasure to have you here in the webinar on security automation from idea to tool. While we are waiting for a couple more minutes for participants to join, it would be nice if you could write in the chat greetings and the country where you are connecting from. It would be nice to see from where you are. You can just use the chat for that while we wait. I have begun the chat saying the greetings from Lithuania. If you see that and you want to share greetings from your country, please do. Let's still wait for a couple more minutes so that everyone who wanted to be here could join. Greetings from Ghana, greetings from Kenya. Karibu sana. Okay, greetings from South Sudan, Cuba, Tanzania, Barbados, Burkina Faso, Mozambique, Lithuania, South Africa, St. Lucia, Trinidad and Tobago, Mozambique, DRC, Congo, Moldova, Kenya, Mozambique, Romania. Really happy that that you are joining our session and webinar. Let's wait a couple more moments so that really everyone who registered could connect. Djibouti, Hamas, Romania, Guyana. Great. Okay. According to my time, it's 3:02 p.m. and we shall start this webinar on security automation from idea to tool. My name is Paulius Daukšas. I'm a cybersecurity consultant from NRD Cybersecurity. Those who don't know us, we are a company based in Lithuania, incorporated in 2013, and our main focus area is security operations center build-out, establishment of computer security incident response teams, modernization, and other cybersecurity capacity building activities globally. Also, we like to contribute to the communities, and this is also, it feels like a community of people who are passionate about automation, who are passionate about how to make their operations more successful and more efficient. So in this community and other communities, we do share valuable information that we are thankful to gather during the projects that we deliver. On the screen, you can see QR codes for LinkedIn and newsletter. So you can scan it and you can subscribe to our newsletter, where we publish the newsletter Collective Cybersecurity on various topics such as CSIRT budgeting, communication strategies, how CSIRTs are established in different small nations such as Jersey, Bahamas, and else, with the interviews with managers of those institutions who run CERTs in those countries. And the newsletter QR code is there as well. We, from time to time, also organize such webinars where we share information and knowledge, what we sense are very necessary to be shared. So previously, 2 years ago, we had some webinars on collective cybersecurity approach, on how to think about building monitoring capabilities for the country from the national cybersecurity standpoint or from the sectorial regulator security standpoint. Then we had some webinars on CSIRT budgeting, how to think not only about establishment, but also how much does it cost to run a CSIRT, right? From people to technologies, building and capacity building, and etc. And today the webinar is about automation. So typically CERTs, they do specific services for their defined constituents, which are written in the mandate. And those services are depicted in particular processes and workflows. So I want to do something, and this is the process that I will follow to achieve the desired outcome. Typically in CERT world, we see that still there are a lot of manual work. Also, there are other pillar of CERTs who are heavily automate. That automation can be done via in-house engineering. So big old CERTs, they have engineering capabilities and capacity built already within their institutions, so they can think about mature operations, mature automations that they can provide in their life. Other CERTs, they see that there are multiple open source tools which are delivered by the CERTs, by the community, and they try to use them, and they see some challenges on how to really make them operational for their own CERT. And there are others who just don't automate because it's not, for example, feasible for them, and working on spreadsheets or on other manual tools, it's okay, and they are operational and successful. So it really, there is no one right way on how to do. This webinar is more on sharing how to think about automation. If you are already mature CERT, maybe you can add something. If you do operations still a lot of them manually, so you can have inspiration on, okay, so maybe I can learn something from this. What tools can incorporate into each other and integrate and create some automated workflow. And I also really encourage everyone in the chat. We have quite a good amount of people here to also maybe try to find peer connections. Maybe you know someone from the greetings, which are neighboring countries or the countries that you have some conversations. So probably these are the people who are in the CERTs. We can maybe somehow exchange contacts and have some peer discussions after this webinar as well. So also, lastly, what I wanted to share is that we are welcoming all the questions. You can write them in the chat throughout the webinar, and at the end of the webinar, we would be able to look into them and comment and elaborate on them. I have my colleague Marius who will be doing the webinar. Marius is a very nice fellow. He works with CERTs from 1999. So in 1999, I was actually going into the first grade in the high school. So since then, Marius was already working with academia in Lithuania and building CERT. Running that CERT, then he moved to NRD Cybersecurity, where he goes to various countries helping to automate their CERT operations. Now I will give a word to Marius. He said that he planned to have 40-minute webinar. So that means we will have 10 more minutes for questions and answers. So thank you so much. Enjoy, and Marius, take it from there. Thank you.
Thank you, Paulus. Let's go to the topic of today's webinar. Paulus introduced me. My name is Marius Surkis. I'm going to talk today about security automation. Actually, not any security operations, but specifically threat hunting operation, threat hunting automation. Going to demonstrate, probably going to discuss how to automate this particular process. Short about me, actually, Paulus introduced me a lot. So I work in CSIRT SOC area for about 25 years already. My activities in the company is building tool sets for the CSIRTs, established CSIRT SOCs, enhanced CSIRT SOCs, work on infrastructure tools and similar projects around the world. Let's move to the topic. So, threat hunting and automation. First of all, let me introduce threat hunting. Probably it's already known thing. What it is. In fact, it is some proactive efforts making searches for some research for cyber threats in our infrastructures, in our environment and network, which actually somehow left undetected previously by our regular detection, by our regular monitoring tools. We also have quite very well-known approach how we do threat hunting. First of all, we raise some hypotheses. We get some ideas about some threats, cyber threats from CTI sources, from different articles in the internet. By doing our own research, we get some information about possible threats. We collect indicators from these researchers, from these articles, from CTI sources related to some specific topic or some specific threat. We go to our monitoring facilities, detection for infrastructures, looking at logs, IntelOwl logs, NDRs, ADRs, SIEMs, or whatever we have, and whatever we use during for monitoring purposes. Finding something, studying it, analyzing behavior, analyzing activities, what we found, and in case it is true positive finding, we pass all this information to the incident handling process. We start analyzing, we start dealing with incident, analyze incident, triage incident, and do some response. So more or less general workflow how we do these activities. First of all, if we look at the first part of the workflow of the process, we have to deal with a bunch of indicators. We have to get some indicators. We have to get some initial ideas for our hypothesis. How we get them? A lot of sources in the internet, a lot of information in the internet we can find. Different research groups, researchers, CSIRT teams analyze APTs, analyze malicious activities, and publish reports in the internet together with indicators, and we can use them for our further investigations. We can receive a lot of information from our fellow teams, from our partners, from CSIRT community, in form of CTI events, indicator collections. When we do our own analysis on the incidents, when we do investigations, we can find a lot of different indicators, IP addresses, FQDNs, URLs, which we notice they are used in the attacks. So we can collect such indicators and again, we use them in our threat hunting process. So about indicators, for another part of the threat hunting, we have to deal with detection infrastructure. We have to approach logs, as I said before, NDRs, XDRs, whatever we have. In my examples here, I'm going to use, I will be showing our own detection infrastructure, what we have. This part of implementation can be different from team to team, how they implement detection, how we implement monitoring of their constituents. In our case, we put sensors in constituent networks, collect data, save them, and we have some central management facilities which we can use to query all this data to get results. In fact, this is on the back end. It is based on Elastic, so in fact we are using Elastic queries at the back end to search all this data. As I said, different implementations can have different approaches. There can be different themes, can be different NDRs, implementations, and so on. So in my here in today's presentation, I'm going to follow Elasticsearch, Elastic Stack implementation. So we have indicators, we have detection, and actually we have dilemma. We get zillions of indicators from third-party CTI providers, from OSINT, from internet, from CSIRT community, a lot of tens of thousands, hundreds of thousands indicators each day, and it's quite not so easy task to process them. From other side, we have millions of events each day. If we have wide infrastructure to monitor, big infrastructures to monitor, we get millions of network events each day, and this also not so easy to process. So at the end, definitely we need some automation here to do efficient renting. That's probably quite difficult to do by hands only, right? So automation needed. Let's sketch. Let's make a initial sketch for our automation implementation. What kind of playbook we want to build here? First of all, intelligence collection. Definitely we need to automate intelligence collection. A lot of the we probably will have a lot of intelligence, but it should be automated somehow. Second point, we have to assess CTI data, select which actual CTI data we need for our renting operations, which is important for us, which gives us more value, and select somehow what we are going to use. In these examples, I'm going to focus on APT-related CTI data. So in other words, if some partner, for example, CSIRT team finds some new indicators related to some APT group, some threat actor group, I want to take these indicators in automated way, query logs, and check. Maybe in past few months, I also got some this kind of indications for APT in our infrastructures, what we monitor, right? So this is my task for today, for today's implementation here. If I find something, I will register incident, will raise incident to start to pass all this collected information to the incident handling process. And also I want to orchestrate somehow initial analysis, triage part, to help analysts with further action. So overall, I have 5 steps, 5 parts, what I want to automate. And this is what I'm going to talk during this webinar. So let's go one by one. Step number 1, collecting intelligence. How we do this? For this, we actually have very well-known tool MISP, malware information sharing platform. It is really known in CSIRT community. You can give thumbs up who using it, who familiar with the tool. And this is CTI management tool designed for sharing, community driven. That means a lot of community members, CSIRT community members uses it, shares information using it. Another good important thing for me is to cast REST API. That means actually that I can use it in my some automated playbook. That's very important for me. Yeah, for those who are not really familiar with MISP, I quickly will go through what you can see in MISP, how this threat intelligence looks like here. CTI data indicators are organized in some objects, event objects in MISP. And in event, you can have a lot of different information. In particular, well, some generic information like subject, creator organization, also indicators, which actually I'm going to use in my further threat hunting operations, taxonomy, patterns. But important for me is attribution to some threat actors, APT groups. Also some correlation information, and actually what is important also for me is capability of MISP to indicate some potential false positives. MISP has some mechanism to indicate potential false positives called warning lists. And if MISP shows that some indicator correlates with warning list, that means that I have possible false positive. What else here? Yeah, so basic information about MISP and what you can find in MISP, right? Also, another important thing, MISP is actually ready for data exchange. MISP is designed for that. And when you deploy your own MISP instance, you can connect your MISP instance with another, with your partner MISP or maybe community MISP, and you start exchanging the data. You can start receiving, you start sharing with others. Threat intelligence, what you find, and receive threat intelligence what other teams find. So it's very important that it is very easily implementable, and you can easily get this initial value from the tool. So at this point, we have tool MISP, we have threat intelligence coming. Let's go to the step number 2, assess CTI data. In this step, I'm going to introduce another tool, which is open source SOAR tool, security orchestration automation tool. What it does, it allows you to design your own playbooks, your own automated workflows, combining triggers, combining applications into some with single automated workflows. It allows you to import some additional new applications. If application has API, it's very easy to import. It's very easy to integrate in the SOAR and start using it in automated playbook. In the playbook, you define how you authenticate application, how you receive information from application, how you process the data, and how you pass another part of the data to another application, and how you make your results at final stage. This automated playbooks can be triggered in different ways. You can make a schedule them by specifying how frequently it has to be executed, or you can create webhook for the playbook, allowing trigger execution remotely. So when some remote application sends some data to your webhook, this workflow starts being executed, and this data starts being available in your workflow at this point. So at this point, well, where we left MISP, we already have MISP. MISP instance. We connect another MISP instances to our own MISP, and synchronization starts providing some CTI data from partners, from community. Actually, we also can have our own CTI specialists, CTI analysts, who can add their own findings into the MISP in form of CTI events. And what we have to do now is we have to select important for CTI data, feed such data to the shuffle, to our SOA system. How we can do this? MISP has a very nice feature called workflows. Workflows allows actually expand functionality of MISP according to our needs. So we can create specific workflow which is triggered on event publishing. So when new CTI event comes to our MISP, it's being published and this workflow is being triggered. We add some condition. If in the taxonomy we have threat actor specified, and that means in such a case, if event is attributed to some specific threat actor, this workflow will be executed, and such events will be sent to zero-on-queue channel. Zero-on-queue channel is another functionality of MISP. MISP can send event data to the zero-on-queue channel to provide this information to some external applications. And here we connect shuffle listener, which actually feeds such data into the MISP workflow, threat hunting playbook, into the webhook of that playbook. So at this particular point, such data starts being available when MISP receives such information, such event attributed to the APT actor, to threat actor, some APT group. Such events through a workflow to zero-on-queue channel is fed to the shuffle. In such a way, we connect two different applications and integrate to each other. Okay, so at this particular point, we already got CTI in MISP, selected specific CTI data, which is attributed to APT, and shuffle already can process such information and we can go to the next step number 3. We can use this information to search logs. This particular step is as I mentioned before, it's very dependent on the detection infrastructure, on the monitoring infrastructure, what you have, what CSIRT has on their side. I mentioned I'm going to follow our own example. We store all logs, all events in the Elasticstack database. So that means we can use Elasticsearch API to make a query. And here we implement additional steps in the shuffle, in the SOA system. We will be collecting specific indicators and making queries, executing queries in Elastic. So first of all, we have specific MISP event. MISP event which is attributed to the APT, some APT group. From this event, we set up another API query. We retrieve indicators which are specific type, some IP addresses, FQDNs, hashes, URLs. We take all such attributes, so all such indicators, which actually are marked for IDS usage in the MISP. Analyst can, when analyst creates event, analyst can flag each attribute. Is it each indicator, if it can be used, if it should be used for detection or not. So we are going to use this particular flag to select only attributes which are which can be used for detection, and also reinforcing usage of warning list to minimize possible false positive findings. So at this point, we select indicators, sort them out, create Elastic query, and execute, send the request to our Elasticsearch cluster to search for possible data, possible for findings for last 60 days or 3 months or half a year. And receiving some aggregated data, some summarized aggregated data, what we find by using this, with these indicators. Yeah, so at this point, what we have, we selected indicators, executed query, and if something is found, we have to register incident. All right, we should initiate incident handling process. So let's register incident. To register incident, we are going to use another open source tool, ticketing system request tracker for incident response. It is also very well known to in CSIRT community. It has some specific CSIRT specific incident handling workflow, and what I specifically like with this tool is it's highly expandable. It has quite good capabilities to expand the functionality. It has internal logic actions. It has possibility to expand, to change behavior, to change interface or backend operations by using callbacks, overlays, extensions. Also, it has REST API. That means, of course, that I can include them. I can add this tool to the to our automated playbook. So let's do ticketing orchestration. We add additional application to which actually approaches ticketing system with API call to create a ticket. To create a ticket in specific queue with specific subject, with content taken from Elasticsearch findings. And as a bonus action, we will be notifying our team. There I can use Discord, I can use Teams, I can use Mattermost or whatever other two team uses. We can add some additional notification to our team, bring analyst attention that, hey, look, something happening, something was found during threat hunting operations. And as a result, what we have as a result? As a result, we have Discord notification to our SOC team. Hey, look, there is a MISP event and with some APT data, and we made threat hunting operations and found something. All details are in ticket. Analyst clicks on ticket, and we have in ticket all the results with indicators and with summarized information telling that some IP address approached DNS server and queried for some suspicious IP DNS names, which most likely related to APT. Yeah, so at this particular point, we did semantic operations and made a ticket with documented findings. And let's go to the last step, to analysis step. We have a ticket with indicators. What else we can orchestrate here? Actually, as another step in the incident handling process, analyst has to do some triage operations to make sure that it is not false positive. It is some really malicious operations. How we can orchestrate here? We can use another open source tool, IntelOwl. What IntelOwl is actually enrichment automation tool. You can provide some observables, indicators, IPs, domain names, what else hashes, and IntelOwl uses different analyzers, approaches different engines like VirusTotal, ThreatFox, URL House, and etc. And IntelOwl can combine such analysis into one single playbook. So we can use some playbook to run some standardized operations for triage processes. And also, what is good, it has REST API. That means we can use IntelOwl in our SOAR operations, in our SOAR shuffle playbooks. So let's do this. Because before this, another thing is, well, how I want to execute it, right? I want to give my analyst capability to selectively click on, to provide a menu, to let analysts click on specific playbook and to in order to trigger it. So by default, our ticketing system, RTIR, doesn't have such analysis capabilities, but it has good expansion capabilities. I can expand functionality of request tracker. So actually, I can implement such a menu by adding some extension, which adds additional menu, analysis menu, and associates each menu item with some webhook URL. You can find the source code of such extension on our GitHub page, on our GitHub repository. So how it works: when analyst clicks on the menu item, like clicks on IP reputation playbook, webhook query is executed by ticketing system and query sent to shuffle a specific workflow. Shuffle retrieves indicators from ticketing from the ticket, sends these indicators to IntelOwl. IntelOwl queries all the CTI engines, what is configured, receives information, and Shuffle adds nice looking report to the ticket for the analyst. It takes about a minute or 2 minutes to execute and to give a result back. And as a result, analyst receives good extensive report about some malicious indicator. If we have some IP address here, right? Me as an analyst, I receive reports from different providers, from CrowdSec, AbuseIPDB, AlienVault, VirusTotal, which all provides a lot of different useful information for the analyst, and analysts can then work on further decisions of what to do with this particular incident. Is it false positive, not false positive, and saves much time for analysts for analysis. Yeah. And yeah, so actually we did 5 hour steps in our threat hunting playbook. We used MISP, Shuffle, Elasticsearch, RTIR, IntelOwl, and more or less our mechanism, our robotic implementation is ready to work. Just to mention one more thing. before putting into the production, we also have to think how to tune this mechanism, because every SOC actually has to be ready to improve the implementations, the automations, and we have to plan what tunable parameters we have here. Why we need to tune it? One thing, we would want to improve our findings. Another thing, we have to think about how we are going to reduce false positives and false negatives. And yeah, so how we do? We have some bolts and nuts what we can tune here. One thing, queries and shuffle. We adding some queries to MISP, queries to Elastic, so we can tune them to adjust our findings, to widen our findings or narrow them down. Also, we can manage false positives, controls. We have some control on false positive findings. We have multiple warning list, enabled in MISP, so we can disable something if we see that it results in false negatives, or maybe enable something additional. We can create our own warning list if we have some specific IP addresses, specific URLs, which generates a lot of noise. So we can also tune this part. Another thing good to have when you engineering some workflow, you can think how to implement some blacklists on indicators, some whitelists on indicators, so we can implement some specific tunables parameters in the automated workflow in a SOA system. So we can easily add some, for example, in this example, some DNS name which could be ignored, which could not be used in our queries to reduce false positives. So some things also to plan, to know, and to do. And I come to my last slide, conclusion slide. I want to emphasize 3 major points: community and global efforts. First of all, CSIRTs and researchers shares a lot of great information. Results from their daily work, from daily investigations, from research efforts. And this is a really powerful thing here. Intelligence shared by CSIRTs and researchers, malware signatures, TTPs, IOCs that supports SOCs and CSIRTs in their daily operations, and actually that leads to faster incident response times, improved hunting capabilities, and overall more resilient security postures. Open source and flexibility. It's another thing that gives us big powers, and open source allows to adjust tools to our own needs, and actually this flexibility allows to tailor security operations to our specific needs and enables collaboration. Actually, at final stage, it enables collaboration broader cybersecurity with broader cybersecurity community. And engineering as a glue points. When we leverage API, source code engineering, we can interconnect different various security products such as SIEMs, threat intelligence platforms, incident response tools, maybe vulnerability scanners. So we can wire them into one single unified automated workflow. And actually that allows deep customization and development of some tailored logic in our implementations. And actually, this is and I approach the last slide. And maybe you have questions. Let me check. Questions and answers. Okay, so I have some questions here. Question and answer section. How often are your CSIRT sources updated, especially as it relates to zero-day attacks? Actually, it highly depends on the source. If we talk about zero-day attacks, there are some in our implementations, actually we use different kind of sources. One is free, openly available, open source threat intelligence providers. Usually what we can get from them is IP addresses or URLs which are used for phishing campaigns, for brute forcing, scanning, and so on. If we talk about zero-day attacks, usually you would want to receive such information very efficiently, very fast. Well, you need some specific CTI providers. Some of them are available. Some of such data is available well, from proprietary CTI sources. Some such information you can expect from CSIRT community. But well, also you should assume also efforts from your own team. When you get such information by your own team also should contribute to threat intelligence repository and to add such information by yourself. So there is no very good single answer to this question, but I would suggest you assuming different kind of sources, some proprietary CTI providers, community, and actually your own team. Can you generate, another question is, can you generate incident response reports daily? In fact, it depends what you mean, the incident response reports, but well, ticketing system has such capability to generate reports on daily or weekly or monthly basis. And you can generate, well, actually, ticketing system in this case, it takes as an information source, it takes tickets. What kind of tickets? What is the taxonomy of these tickets? Indicators and so on. Can summarize some information and can generate reports. Send these reports by email. I'm not sure if it is if I answering the question, if I understanding the question correctly, but if it is talking about incident response, I assume that it is related to the reports which are registered as tickets in the ticketing system, probably. So yeah, ticketing system has this capability. Can you share recording, please, after the session? A recording is in progress, I guess. So I think recording probably will be shared, but maybe maybe my colleagues can be more specific on the sharing of the recording. Another question, will the presentation will be shared with the group after the webinar? So it's same probably question. I will leave it to my colleagues. Do you use this tool for managed SOC service? Yes, actually, most of these tools we use for our own managed SOC services. So mostly yes. And another question, do you have any other recommendations for open source ticketing? And also your opinion about OpenSearch. So open source ticketing, there are some other tools. Well, for the another popular tool for the ticketing was RTIRs. However, as open source, you will not get RTIRs. Well, last version of RTIRs is still proprietary one, according to my knowledge. What else you can use for the ticketing? I'm not really aware of good open source ticketing to another version of good open source ticketing tool. Some of them are outdated, some of them proprietary. Maybe if audience has some ideas, some suggestions about other open source ticketing, please help me with this question. And regarding OpenSearch, well, it's good as a platform. It is good tool, and as a backend, I guess I would achieve the same results if I would use OpenSearch instead of Elastic. So nothing cannot say any disadvantage of using OpenSearch here. Another question, just to clarify, in your workflow, Elasticsearch would be a SIEM. That's where you search logs. Actually, yes, we use Elastic to collect the data. Also, our Elastic implementation has a lot of different useful dashboards which analyst uses to get their findings, ideas efficiently. I did not include such a dashboards in presentations here because that was not my intent. But in fact, here I'm using just a Elastic API. So I'm interested here with my implementation. I'm interested only in getting the raw data from Elastic. Right, make queries and get the data. But in fact, yes, we use Elasticsearch as a SIEM, and it works quite well. But me, actually, I'm using a pure API from Elastic Stack. Another question: can artifacts be attached to the RTIR ticket other than reports? Well, artifacts, I assume, is some indicators. Usually when we deploy RTIR, by default, RTIR can have IP addresses as indicators, domain names as indicators. We also additionally add caches and URLs. Also add some functionality related to these particular indicators. Also, RTIR can have attachments. Some files can be attached to a ticket, and also we can execute some analysis on them and implement some automation on attached files. For example, if it is malicious files, you can probably not really difficult to make similar analysis menu to send all attachment to a sandbox or to some, I don't know, some other file analysis engine, and to get the reports on such attached files. So I guess this question is about that. Okay, a few more questions. What programming languages do we still have time? Yeah. What programming languages or scripting tools are most effective for developing custom automation scripts? It depends. It depends on the tool. In the shuffle, usually Python should be used. And if you're trying to expand RTIR, request tracker functionality, parallel language is a way to go. But in fact, the language is not really thing what you have to choose. I recommend use the language what you are more comfortable with, and it probably it will be possible to automate something. What other ways can automation assist in incident response and incident management? Actually, you can implement different things. You just you need some ideas. What I was implementing before is some automated instant creation when some critical system is affected, and I receive information from CTI that some critical system is affected, create incident in real time. Make a report, send these reports on CTI data like shadow servers, distribute shadow server reports to constituents in automated way. Then I don't know, do vulnerability assessments on indicators which are attached to a ticket. A lot of different things that you can do. So I don't think it's you know that your imagination is a limit. And another question, the last one: in what ways are security teams leveraging LLMs such as ChatGPT or Llama to enhance their granting capabilities on streamlining incident analysis workflows? Yeah, it's a good one and tricky one. There are some things. What I saw, well, actually, Shuffle also can have some capabilities to use artificial intelligence for some decisions. For example, well, I would just guess you can feed some reports to the artificial intelligence to help with some taxonomy, with some initial assessment of the report. Also, I saw implementations. If you're familiar with honeypot teapot, well, you can find a honeypot solution in our GitHub. It has some honeypots included, which you can use artificial intelligence to simulate some specific vulnerabilities and to pretend being, well, actually execute some honeypot capabilities as high interaction honeypots. Well, it's LLM can be used for this. Of course, you need either graphical GPUs to execute it, or you have to use some services from the cloud for that. But yeah, so there are some efforts doing this, and for me, it's probably still some time to research how LLMs can be used in best way, in best approach. But this part, set hunting and other automation can will be using, I think, in the future more and more. Yeah, so I went through the questions. I hope I answered them.
Mario?
Yeah.
Can you also click on Q&A? There are
actually this is Q&A. This was Q&A. Actually,
sorry, chat function.
Chat.
Yeah.
Okay.
Maybe a couple more questions still.
Okay. Let me see chat. Yeah. Good. Let me start from the beginning. Okay, sharing presentations. Okay, question from Arnold. We are managing a metropolitan network with heterogeneous systems and private SOCs. How can we efficiently collect and consolidate security-related information from these various, often proprietary systems? Well, it's quite not so easy. It's quite a difficult question. It depends on these proprietary systems. Anyway, you need somehow to collect logs. Some of these even proprietary systems hopefully has some syslog facility how they can send logs. So, but this is probably can be difficult question, and well, there are different things. You have to think how these systems can send logs, which software can be tuned efficiently to collect these logs. Some of the systems are quite easily configurable, so that may probably complex solution for this. I don't think maybe it's quite difficult discussion how to do this. What is the limit of analyzing this ticketing? Do we use Docker for shuffle? What is the limit of analyzing? I'm not sure what does this mean, but in fact, if you mean that, yeah, if for example ticket has thousands of indicators, and if we will be sending all these thousands of indicators to shuffle, then automate analysis, receive thousands of reports, attaching thousands of reports to the ticket, this ticket will be unmanageably big. So a lot of reports probably. So I guess it could be reasonable to limit number of indicators what you are sending automatically and receiving reports. Maybe, you know, computational limit. We can increase some CPUs, some CPU power, memory, disk space, whatever. But at the final result, we can receive unmanageable number of reports. So maybe this particular approach would not be really good with big number of IP addresses. Maybe some different implementation would be needed. In what ways are security teams leveraging LLMs such as GPT? Okay, I think I tried to answer this question, which was in Q&A. What is the difference between IntelOwl and IntelMQ? Can you give detailed explanation and use case on both use, please? In fact, different tools, different use cases. IntelMQ collects CTI from different providers. It's like, it's like a robot. You take data and do something with this data. Collect from certain intelligence sources and build your own logic what to do with it. IntelOwl is you request manually information or manually automatically for one particular IP address, receive information, receive reports, and provide these reports to the analyst. So a bit different use cases. One is to collect, IntelMQ is for to automate collection of certain intelligence, and IntelOwl for to do enrichment on some particular indicator. And for example, IntelMQ can be used to collect state intelligence from shadow server. You can, if you are national CSIRT team, for example, you can receive tens of thousands records from the shadow server per day. So you want to automate this collection and processing of this data. So IntelMQ can be used for this. IntelOwl is just enrichment and providing some analytical information on some specific indicator. And I think last question is, and among all the tools you mentioned, is there a way to give us a workflow on how all should communicate or be integrated? Like an event or alert is picked up from tool A and it does something, then goes to tool B and does something, then goes to tool C, and so please. Actually, yeah, well, this one presentations probably do not list all the details how the data should be processed in each way. When you use shuffle and you take some information, get some information from, for example, from MISP. This information comes to the shuffle in JSON format. You can check MISP documentation on how this internal event data is represented. And then you build your logic in the shuffle, take some other piece of data from this particular JSON structure and send to another tool. Maybe some information should be formatted in some specific way. And so you have to do this in shuffle with some specific internal shuffle operations. So to prepare data to be sent to another tool. I did not go to all these details because it could take a day or 2 days to explain everything, all the details why I do something in the pre-processing data. But this presentation only gives you general idea what tools you can use, what kind of capabilities they have, and it suggests a way to go, a way to implement something. And of course, it does not do all the detailed, all the details of how something has to be processed, converted, and so on. But definitely, when you pass data from one tool to another, with these tools, they are in fact incompatible between each other. And Shuffle has this capability to convert one format of data to another format of data. In the automation process, is there any other process which ensures that all processes are always running properly? Yeah, it's a good question. It's actually definitely in any infrastructure when you implement something and you maintain some infrastructure, some tools, deploy some tools, you have to monitor that they are running properly. Usually we are running all these tools as a Dockers. So our monitoring system should regularly query all the systems and check if Dockers are running properly, if Dockers are healthy. So yeah, this question is about general hygiene of the IT infrastructure. Definitely, you need to monitor, and you need some tool which monitors all this infrastructure and ensures and notifies if something is running wrong.
Thank you a lot. We are over the time a bit. There was a very big question whether we will share the videos and presentations. Yes, we will. How and on what format, I don't know. Maybe a video for YouTube and the link and the slides. Somehow, maybe you will write to us, we will send you. So yeah, we will definitely sort this out so you can have it. In terms of automation, please consider 2 things: that you build a process, and once that process is repetitive, you think on how to automate. Automation will not replace humans. It will only reduce the fatigue and improve the operations that the humans are running. So thank you all for participation and good questions. Thank you, Mairo, for your time today. If you have any topics in mind, what you would like to have a webinar in terms of CERT, let us know as well. We would be happy to look into that. And if there is a need, we would grasp that there is a need. We could definitely do another one in the future. Thank you, and have a good day of the rest, good rest of the day, or from where else you are. Thank you so much, and goodbye.
Thank you. Bye.